Hello everyone. Today I will explain about the extraction process and what is extraction and how to do that. So before showing you practically, I need to know, all of us need to know what is extraction and why we need to do that. So first of all, in the organic lab, we do reactions, chemical reactions by mixing different reagents. Suppose A one reagent and B another reagent, and we mix together in presence of any acid or base. Then, once the reaction is done, then we stop that reaction or quench that reaction by using water or any other aqueous acid or base. If you use acid in the reaction, so you have to use base, sometimes water only, to stop or quenching the reaction. On the other hand, if you use acid then in the reaction, then you have to stop the reaction by using base or water. Maximum time water, but sometimes you need to quench or neutralize the reaction, like either acid or base. So since you have to stop the reaction, like organic reactions, organic things is organic reactions. So with the organic compound, if you use aqueous solution like water or like base or something, so those will not mix together. So that is the beauty of the extraction. So in the chemistry there is a proverb, like dissolve like. So organic solvents or organic compounds dissolve in the organic solvents or organic compounds, and water will not mix with those things. So water is very polar solvent, so water will dissolve or water will take out the acid or base or remaining any other inorganic part like highly polar thing. So organic compounds are normally non-polar or like very less polar, so organic solvent will dissolve organic part. So by this way it will make two different layers, and from that two different layers you need only the organic part, which you can separate by using the separatory funnel. I will show what is separatory funnel and how to do that. And this process is called extraction. That means you are separating organic versus the aqueous part. So there are two different layers you will collect, and your organic compound will go definitely with the organic solvent. So that's how we will do. Suppose you have reaction. So once this reaction is complete in a roundable class, so it is a reaction mixture. So you have to quench the reaction mixture by using any aqueous system like acid or base or water. After that, we will use a separate funnel like this. So organic part is on the top and aqueous part normally on the bottom, but it is not always correct. Sometimes organic part also can be down and aqueous part can be up. Especially it depends what is the solvent you are using for the extraction. If you use the DCM, dichloromethane or chloroform for this extraction process, then the organic part will be on the bottom. So in case of it entirely depends on the solvent system you are choosing for the extraction. So if you use ethyl acetate or diethyl ether or any other organic solvent, so those should be on the top of the separatory funnel. So now I'm going to show you practically how to do the extraction. Let's move. Reaction mixture in the round bottle flask. So now I will add water to quench this reaction. So normally if we add water, definitely you will see two different layers. This is water actually. So you can see there are two layers. Right, like top layer is organic and bottom layer is water. So now we have to separate these. How we are going to separate? So we will use this separatory funnel, which looks like this, and it is very useful to separate organic versus aqueous layer. So there are two thumb rules for the separatory funnel. What is that? So before using any separatory funnel, make sure like close this. So this is open and this is closed. Close this one and take some water and make sure that it is not dripping or not leaking anything here. So it is not dripping, it's good, not leaking. And there is another rule, whenever you have to put in a ring, separatory funnel ring, so carefully put it here, and you have to always keep a aluminum flask or beaker just the bottom. Especially the beaker is very important. If you can put a beaker, so beaker during pouring the solvent, if something is dropping outside, so beaker will catch those solvent. Now I am going to separate this part, organic versus liquid. So I will pour this on top. Also wash these with organic solvent, the solvent which one I want to use for the extraction. Now make sure that something is right bottom, and now we are going to use a stopper. So using stopper, I'll take this out. Before using the solvent mixture, make sure that after attaching the stopper, it is not dripping anything. So you have to invert it like this in your thumb, hold it like this, and then release the bend like this, and then close this one, and then shake it. Again, release the bend, while it will be like this in your hand versus this, and then close it and then invert it ring, once you put in the ring, after shaking, so make sure that you remove this cap. You remove this cap and put it somewhere down, because if you don't remove the cap, then those will not separate nicely. So give little time to get separated, and you will see organic layer will start separating from the aqueous layer. And once that layer gets separated, then you can take out the bottom layer, one flask, and the top layer another flask. And this process is called extraction process. So let it be separated two layers. So if you see that there are two layers, top layer is organic and bottom layer is aqueous layer. And if now you can open it, part is here and bottom part is there. Do not throw it. And then once your organic part, so you will see very small amount aqueous layer is still there. If you see closely here, the bottom part. So I will take this out also. So very carefully. Okay. Now, if you have the organic part, so you have to take the organic part from the top, not from the bottom, because you just take the bottom aqueous part. So take the organic part from the top, and then use that part again. Use again the same, that aqueous part, use more solvent on it, organic solvent. So normally in the extraction process you have to do at least 3 times extraction, same thing. So every time you will collect the organic part and then do the extraction process again. So I will use this one and then I'll hold it and then I'll make it up like this. Then shake it, and open the vent a couple of times, because it will create some pressure inside. If you don't bend out, so it may propel out or like it may explode. So, and close it again and shake it again and open it again, like to make sure that all pressure is out. Then close it and then invert it like this. So the thing is, you have to always hold it like this while you are shaking. So invert it so that you can release the pressure like this. And so shake it like this and release the pressure like this. And while it is hold by this in your thumb, it is open now. But to invert it, make sure that you close it, then you invert it. And again, you have to remove this cap and put it in the ring. So make sure that to settle down to separate layer, you have to keep this, take out this out and keep it, and in the bottom keep the aluminum flask, especially normally use the beaker. So and once it gets separated, then you can take out the aqueous layer. Bottom layer is aqueous layer because I am extracting this process with the ethyl acetate. Ethyl acetate is lighter than water, so it will be on the top. But if you use DCM, dichloromethane, or chloroform, that is heavier than water, so those things will be bottom. So keep it in your mind while you are doing extraction. If you follow any procedure, the procedure says extracted by DCM or chloroform, then make sure that those layer will go down bottom because they are heavier than the water. But if you use ethyl acetate or diethyl ether for the extraction process, so you will remember that the organic layer will be on the top and aqueous layer will be on the bottom. So this is the basic technique for the extraction process. I'll just take out this aqueous layer first in a flask, and then I will collect the organic layer in my desired flask. And after collecting that organic layer, then I will use magnesium sulfate, anhydrous magnesium sulfate, to dry the remaining or trace amount of the water in this organic layer. So suppose if I collect all the organic layer, and after that I will use the magnesium sulfate here, and I swirl it to make it dry. Like if the magnesium sulfate is freely moving, that is called free floating or moving, that means there is no water anymore. The remaining or trace amount of the water is taken by the magnesium sulfate. Then I will use a filter paper and the funnel to filter that my compound with organic solvent, and it will keep out the magnesium sulfate in the filter paper. And this is the whole process for the extraction. Okay, I hope it will help you to understand extraction process and how to do this technique. And if you have any question, please write a comment or question below in the video. Thank you. So here I am filtering the liquid in a flask so that I can do Rotavap. How long you filter it, like you can keep the solvent layer. You will see every flask has a certain this white thingy, so you can go up to that white mark. In that case you will be safe in the Rotavap, like it will not pop out. But if you take more of that, like more than half, then in the Rotavap solvent will pump out. So to be safe side, you can take that much amount, and after that you can start Rotavap. Hello guys, Musharraf again. Here I will show you today how to use the Rotavap. And what is Rotavap? Actually rotatory evaporator. So this is a device which will use the vacuum line here to create the vacuum, and there is a condenser, and there is a source like two tube line. So source, water, cool the water in, condense, cool down the condenser, and cool the water, hot water go out. And to do this, there could be many sources. So in our system we have a chiller, so that chiller normally goes down up to -10 degrees Celsius, and there is some liquid used inside for this chiller, so I'm not going elaborate for the chiller purpose. So it just supply the cold water, and it round through the condenser and go out to the other line. And this is the solvent trap. Like once it evaporates the solvent, it will deposit here. And what is the purpose of this Rotavap? Before going there, So Rotavap consists of two things. One is hot water bath, so you can control the temperature by using this knob, making the temperature like whatever you want, degrees Celsius. While we are not using, we normally keep it as 0, but when we need it, we can increase the temperature, and you will see like it will start boiling up the water. And this knob, it actually rotates the whole thing. I'll show you when we attach the things, then it will be perfect for the Rotavap. So what we use this flask. This is called anti-splash flask. So if you attach the flask here, and we normally use this clamp, it is called cake clamp, and there are two things. One is a smaller ring, another is bigger ring. So always the smaller ring will be on the up, and to connect these two to make it so that it cannot detach while you are doing the Rotavap. Okay, now I have the compound here with the solvent, so I want to remove the solvent, but my compound will be here in the flask. So what I will do, I will attach this one, and then I will attach the whole thing here, and I need another cake clamp here definitely before making the vacuum. Before starting the Rotavap, I need to attach another cake clamp. Carefully attach it. Okay, so everything is set up fine. And the vacuum source, there are many options. There are many devices to create vacuum. So we have the water aspirator to create the vacuum. It doesn't matter what is the vacuum source. So just you need to know where is the vacuum and where is the place you need to switch. So I'm making the vacuum on. So there is a vent out. You can hear it creating vacuum. So before close the vent, I will start rotation first, slowly, and then I will close this vacuum vent. So there is no vent now. And now it will start removing the solvent. You'll see how it removes the solvent. You'll see like the solvent will come here and it will condense, and then it will come back. Already it is coming. See, the solvent is coming back here. So basic principle is this solvent is getting evaporated or like vapor phase with the heat of the water, and you have to also rotate it, and then it will go through here and it will go as a vapor, and with the condenser those solvent will condense, and then it will create liquid, and then it will come back to this flask, and slowly all the solvent will be gone. So make one special technique here to remember. When you are doing, if you see something is bubbling, so that means solvent is going. But if it is too much of bubble, then sometimes you can release some vapor, like some vent. You can open the vent so that it can stop like a splashing, like pumping. So to protect the pumping, sometimes while you are doing, just make quick vent out, and that's the way you can remove all of the solvent to make your flask with only the compound. Although with the Rotavap the complete evaporation is not possible, sometimes some solvent stay with the compound. So to remove that trace amount of the solvent, we use another technique. I will explain later in my another video. Hopefully this video will help you to learn how to do the Rotavap. And if you like my video, then subscribe, share, and like us. My channel name is Time Travel. Thank you for watching. Bye. So you can see that the solvent is going and it is condensed down and it is going depositing. So we don't use this part, so it will go to the waste, but normally we will concerned about the product in our flask. So once all the solvent will be gone, so only the remaining compound will be in this flask.